So allow me to introduce. Our esteemed speaker, Dr. Mahendra B. Ghat, have received the BE degree in electrical engineering from Walchand College of Engineering, Sangli, Shivaji University, Kolhapur, India, in 2008, and MTech degree in Power Electronics and Drive from National Institute of Technology, Warangal, in 2010, and the PhD degree in Electrical Engineering from IIT Bombay in 2019. He worked as an assistant professor in Raja Ram Bapu Institute of Technology, India, from 2011 to 2013. He is currently working as a hardware lead at Siemens Research and Development, Mumbai. He has published many journals, papers, attended many conferences. He has more than five patents in his credit. His research interests include power electronic converters, high voltage direct current, e-mobility, storage, photovoltaics, and electric drives. So, with this brief introduction, I will now hand over the session to our external speaker. Please, Doctor.
Yeah, thank you for the introduction, and thank you to giving me the chance to uh, share my knowledge, or we can say whatever learnings we are having now to participant. So I will just share my screen. PPT is visible. Just a minute. I think I shared something wrong. Entire screen. Okay. Can you see my screen now?
Yes, yes, yes. Now it's visible.
Now it's visible.
Yes,
Okay.
yes.
I was not had any format, so I whatever I was having. So with that only I made the this template. So if anything goes wrong, then just sorry for that one.
No issues, no issues.
Okay. So welcome to this 5 days faculty development program on recent trends in power electronics, which is organized by the Vellore Institute. And now today's my topic is electric vehicle charging system. So I'll be briefing on the electrical vehicle charging system, but before that I will just brief why we want this charging system and how the charging systems are there, and uh, how means what are the use, and why we want this vehicle charging system and that kind. Okay, so first of all, if we see what is the trends in the carbon dioxide or the air pollution in all over the world or in India. So if you see the globally, whatever carbon dioxide emission is there, so day by day it is increasing tremendously. So you can see it is going from 1980, the graph is growing only, and still it is growing, and it is a major concern because as the CO2 increasing, the temperature of our Earth is increasing, and because of that, many global warming and all that kind of things are happening in today's life. So for our future or whoever the next generations are coming, so for that we have to take the steps now itself. Otherwise, it will be we can say it will be difficult to control all these things. So all world has already started with the this taking the control. Now, if you consider one of the example of India also, so we are very much affected by this CO2 or the air pollution. So one study, some of the studies had happened. According to that, if you see the air pollution in India is serious issue, and out of 30 most polluted cities in the world, 21 are in India, as per the 2019. So we are 21 cities are there which are very much polluted out of 30 polluted cities. Also, as per 2016 data, people in India are breathing the air which is 10 times or more than the that. is not safe for the our health. So WHO has defined a safe limit of the air pollution. Till that we can breathe, but some people are breathing the 10 times more or more than that uh, polluted air as per the that this data. So it is a very serious issue, we can say, air pollution in India. Now if you consider the total air pollution, almost 51% of pollution is caused by the industrial pollution, then 27%, you can see this I have highlighted because we are more concentrating on this topic. So I have highlighted this as a 27% is the by the vehicles which we are using. So that is the thing. And remaining 17% by crop burning and 5% of the other sources. We have to work in all the areas, but of course, as our topic is related to electrical vehicle charging and all that kind, so now we will stick to this one, that is the 27% by vehicle. Uh, if you get any question in between, then you can just stop me because in presenting mode I cannot see is anyone is raising hand or anything. So you can just unmute yourself and you can just uh, uh, ask the question. Is it okay?
Yes, yes, yes. Sure, sure.
Yeah. And in between, if I lost any communication or anything, then just ping me also.
Sure, 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 sure.
Yeah. So this is the one photo which I took from the Google actually, and you can see the condition of the our capital Delhi. So this is the condition in every winter time you will see the this condition in the Delhi. So the air quality of the Delhi will go very down, and a lot of problems will come. So this is increasing in India day by day, and one major cause of this pollution is the vehicles. If you see in the cities, the vehicles numbers have increased tremendously, and they are causing the more and more pollution, and they are making the more and more air pollutant, which is not good for the our health, and which is causing the more health issues as well. So from this we can say vehicle is the uh, one of the major cause of pollution. Of course, others are there, but vehicle is also one of the major cause to get the polluted everywhere in the world as well as in India. So, what is the option to this? The obvious option is that before that, just I explain what is the transport system. Vehicle means you can say it is a transport system, but transport is a complete where we can say vehicle and all other kind of transporting system also. And now this transport system is a fundamental requirement. Previously, it was luxurious, we can say, but now it is a fundamental requirement. If you want to move from one place to other place, you need say transport also to transport the goods and other things also. But as most of the transport system is our dependent on the petrol and diesel, so which is highly polluting thing, and needs to be quickly replaced by the electric vehicle. Okay, so this is the obvious option, that is the we have to move to the electrical vehicles. So that we are concentrating today. So fully electric vehicles, if you see, so it has a zero tailpipe, means it is not emitting any of the gases which are harmful for the to human or the environment. But it is a not a even though we are saying it is a zero tailpipe, but it is a not a complete green or the non-pollutant option, we can say, because whatever energy electricity we are using, so for generation of that electricity, still we are lagging to generate that the green energy, or we can say the clean energy. Still we are dependent on the like a thermal and that kind, which are still making the pollution. But at this instant also we can say, even though if we generate the energy from the thermal power plant, and this take to the electrical vehicle, and if we use the electrical vehicle, so in this case also, if you see, the more vehicles will be in the city, and most of the whatever thermal power plants and all that kind of there, they are out of city, where we can control the air or the pollution of that one by a controlled manner. But whereas in vehicle we cannot control that one, and in the city it is not possible to control, and cities are getting more and more. So at least we are shifting that pollution somewhere else and controlling there at this moment. But nowadays what is happening, the PV and that kind of the clean energy are increasing their existence, and as time comes, the more clean energy will be there in the use as compared to the non clean energy. So that time we can say the PV electric vehicles are the more environment friendly. But still, this time also there is a need of to use the electrical vehicles, so that we can at least the instantly move the pollution to the outside, and there we can control in a controlled manner. So that is the one thing. Then, as of course now already India is growing in that manner, so electrical vehicle resolution is already there, and you can be the part of it. So you should decide whether you will be going to the electrical vehicle or the non-electric now. Okay, so these are the some issues with the petrol and diesel transport system. So what is the problem with using this type of the transport system is that, if you see, the availability of fossil fuels is limited, and their use is destroying our planet. It is getting day by day, all the whatever available fossil fuels are there, they are getting used, and we are destroy, and to remove that fossil fuel, then transport and all that kind, we are destroying our planet. Then, of course, as I said, the toxic emission from the petrol and diesel vehicles uh, leads to a long-term adverse effect on public health. Then the emission impact on uh, electric. Now, if we compare this with the electrical vehicle, then whatever emission is there, emission impact of electrical vehicle is much lower than the petrol diesel vehicles. Here, one study shows that from the generation to use, it is almost a 60% of efficiency as compared to the petrol diesel, which is giving only 17 to 20%. So if you see this in this condition also, it is beneficial to use the electrical vehicle. Of course, electrical vehicles still have the some other adverse effect, like a battery and recycling of battery. That kind of things are coming, but still, it is a best option as compared to the whatever diesel and petrol engines we are using. As I said, fully electrical vehicles have zero trail pipe emission. But even when if we consider the electricity production, which has the some pollution at the generation stage, so if we compare with that also, the study shows that the petrol and diesel vehicles emits almost 3 times more carbon dioxide than the average electrical vehicle. Then for this tackle all these things, India has already started to taking initiative from the government, and India has the ambitious that they can achieve about 40% of the uh, electrical power installed capacity from non-fossil to the fuel-based resources by the 2030. So whatever thermal which we currently we have, more dependency is India's is on thermal. So as per our ambitious, the 40% of this will be replaced by the some green energy, which is non-fossil type. So there again, we can say the generation is more cleaner, and by using the electrical vehicle becomes a more clean use of that, or more environment friendly use of this. So that's why we can say electrical vehicle are the way forward for Indian transport, and we must switch to them now. Any question with this introduction for the why we have to go for the electrical vehicle? Silent means I will take no question. Okay, so we can say electrical vehicles are the now obvious move for the future transport. So coming to as now we decided that we will go for the electrical vehicle, then we must understand what is the electrical vehicle. So electrical vehicle we can say which uses the one or more electrical motors or the traction motors for the propulsion. Propulsion means to move the vehicle ahead. So if we are using moving the vehicle, so uh, we can say it is using the electrical motor, then it is a electric vehicle. I can hear some anything else there. Okay, sorry. So now, but electrical vehicle, there are many types of the electrical vehicles also. So electrical vehicle can be powered through the, means say, electricity which is on the vehicle or the of the vehicle. Of the vehicle source like a you can consider our train system where the power is transferred through the Pentagon. So there is no source of the electricity inside the train. It is directly taking the power from the overhead lines through the Pentagon and directly using that one. So that is also a one electrical vehicle we can say. So it can be off vehicle source or maybe the self contained with a battery. It can be the battery or we can say the vehicle which has the solar panel mounted on that one and it is taking power from that and using that for the propulsion. So this is also a electrical vehicle. Then also new research is also going on in the fuel cells. So the fuel cell vehicles directly uses the fuel cells inside that one and they will generate the electricity and that is given to the electrical motor to drive the vehicle. So that is also a electrical vehicle. So all that kind of the vehicles which are using the electric motor to drive the vehicle, so they are coming into the category of a electrical vehicle. Maybe it happens that some of the information you already had from the other this thing, but I don't know what has covered and what not. So if you think it is a repetitive, then you can just ask me to skip that one so that we can go for the next slide actually. Is it okay?
Yes, 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 it is okay.
Okay, yeah. And from this type or whatever power source we are using, the electrical vehicles are categorized in different types. So one is the battery electric vehicle, which is fully powered by the electricity from the battery, which is on the mounted in the vehicle itself. So these are the more efficient compared to the other types of the all the electrical vehicle. So this is the one of the growing vehicle system in the Indian market as well. The next comes is the hybrid electric vehicle. So in hybrid, I will just I will show the graphs also. So we can see so the battery electrical vehicle. So vehicle battery electric vehicle how it is. So there will be one battery packs which will gives the power to the your electrical motor and the motor will drive the vehicle. So this is the complete battery electrical vehicle. The next is the hybrid electric vehicle. So the hybrid means it has the engine as well as the electric motor. But connection point of view, if you see, so there is only one source of the source is coming. Here the battery is charged from the outside. So this is the source is directly connected to the battery. Here the battery will not be charged from the outside. It will be charged from the engine which is present and which is running on the fuel tank. So the intake for this one is the only fuel, and it has the engine which will charge the battery as, and in some cases this battery will give the power to the electrical motor, and it will run the engine, and uh, the vehicle will run. So like that system is called as the hybrid electric vehicle. So it has engine as well as the electric motor, but the input is only one, which is the fuel. Whereas plug-in hybrid electric vehicle, it has the both the inputs. One input is the fuel for the fuel tank, which will be stored in the fuel tank, and also the battery. So the battery will be charged directly from the outside, not from the engine. Okay, so it will be charged from the outside, and then fuel will be taken from the outside, which will drive the engine, and battery will drive the electric motor, and that will either engine or electric motor will drive the your vehicle. So this is called as the plug-in hybrid electric vehicle. Now, in terms of the efficient term, the battery of electric vehicle is the most efficient, we can say. Then hybrid is uh, not as that efficient as that of other things. So because we are using the engine itself, and only for the from the engine itself we are generating the electricity to charge the battery. So that is there. In plug-in, it is not as efficient as battery, but more as compared to the hybrid electrical vehicle, because it is a in between. And this market is also growing outside the India. So uh, the advantages of having this one is that till now all the whatever battery or the system is there, so with that you will have the limited range of the travel. But in case of this plug-in hybrid type, you have the both the option. So even though if you don't have the battery charge, then you can use the fuel, and you can have the long range for the vehicle. So that's why this market is also there in outside India. In India, this market is not that much matured, and uh, means till now no one is preferring this option. Only mostly people are preferring this option. So which we can see in the next slides also. The one more, as I said, is the fuel cell electric vehicle. So in this the fuel will be stored in terms of either in hydrogen or other kind, and that with that uh, the electricity will be generated, and the electric that will be uh, driven by the electric motor with that electricity. So this is the one type of the electric vehicle.
I have some small doubt.
Yes,
So in market, if you see right now, there is also an option of mild hybrid and strong hybrid. What does that
yes,
mean in terms of hybrid? Or I think that comes in plug-in hybrid vehicle or
yes. That comes in the plug-in hybrid only, but depending on the battery capacity, it will be mild or the this one. So in some cases, the battery capacity has increased, and some cases very low range, means around a 20 or 25 kilometer only. So that is the mild hybrid actually.
okay.
Yeah. Yeah, so now we will more concentrate on the this part, which is the battery electric vehicle, because our main topic is the um, electric vehicle charging system. So which will be more required to a battery electric vehicle, where the full power is taken from the battery, whereas the big battery bank and it is driving. Okay, so battery electric vehicle. So as I said earlier, it is also known as the all electric vehicle, because there is no other engine and that kind. So it is also called as the all electric vehicle. And electric vehicle using this battery electric vehicle technologies run entirely on the battery powered electric drivetrain. So the electricity used to drive the vehicle is stored in the large battery pack, and then that can be used, which is charged by the grid, of course, and this packs then provides the power to the motors, which will run the car or vehicle, we can say. So main components of the battery electric vehicles are electric motor, then electric motor to drive the vehicle, inverter which will convert the power from the battery to the required to the motor or to control the motor, so that will require the inverter. Then of course battery to store the energy, control module to control all these things, and the drivetrain to drive the from the electric motor to wheel. So whatever drivetrains are there, so that are the main components of the battery electric vehicle. Working principle, so the power for the electric motor is converted from the DC battery to the AC, and this DC battery is charged from the outside, and this AC then accelerate, uh, uh, means as you press the accelerator for this one, the signal is sent to the controller, and the controller adjusts the speed of vehicle by changing either frequency or the voltage or the other, if the motors are other things, then whatever the control is used. So as per that, the change will be happens, and in the inverter, and that will control the motor, so motor speed. So once the motor speed is controlled, so with that, then which is directly connected to the wheels through the cog, and this will drive the car. Similarly, in all the electric vehicles, actually there is a very we can say easily we can implement the uh, regenerative braking. Regenerative braking means whenever we are applying the brakes, we take that power back to the our sources. So that kind of things is easy to implement. So in most of the cases, there will be the uh, regenerative braking. And in regenerative braking, what happens whenever brakes are pressed, the electric car start deaccelerating, and the motor becomes an alternator, and this will produces the power which will be sent back to the battery. So we can improve the efficiency or uh, improve the use of electricity by using this thing actually. Some of the examples of the BEV in India, of course, I'm taking the examples of India only. So are the MGZS. So this is one vehicle. Tata Nexon. These are capturing more market as compared to the other. Then Tata Tigor. This is also started capturing the market. Mahindra E20 Plus, Hyundai Kona, and the Mahindra Verito. Many more are coming, and many more are maybe already there. But these are the some major examples of the BEV, we can say, which are already in our market. Okay. In terms of sales, if you see worldwide, it is tremendously growing. So here worldwide, if you see both the options are growing. Uh, Battery BEV is the complete battery vehicle, and the PHV is the plug-in hybrid. So in out means worldwide, if you see the both are increasing, as it is already crossed to the 10 million cross mark here. So you can see as compared to the world, so still India is lagging, but which is near to 50,000 in 2022, and now it is increasing. But if you see the growth now here, so if you see 2019 there was nothing, but 2020, then 21 and 22, so very sharp rise is there, and same thing is expecting we are in 2023. So in India also and this is for the car sales only, but with this car, uh, means other market like a buses, then the vehicles, e-rickshaws, that kind of the, and two-wheeler, which is the major thing in India at least. So that are also growing tremendously in India for the electric vehicles. So this is one forecast as per the one of the study. So till 2030, uh, world is expecting almost 40 millions of the electrical and PHEV vehicles in the market. And that time, if you see the India's growth also is almost 2 million. So a very big market is there for the electric vehicles, and it is growing. It is good thing. We are growing in the electrical vehicle, but parallelly, as I said earlier, we have to grow in the clean energy also, instead of depending only on the thermal and that kind of. But already that initiative is also taken by the government, not only for the India, because uh, if you see worldwide now, everyone is means concerned about the this global climate change. So everyone has to take the action. Then only we can achieve the or we can say make a safe future actually. Okay, so this data is shown for the car sales, but similarly there will be increase in other transport system, as I said, for the trucks and buses. So this is also one major contributing thing for the pollution actually, trucks. So our Indian trucks are worst actually, we can say, as compared to the other trucks or other this thing, and they are also contributing more to the pollution. So, but as I said, the same trend is now going in the trucks and buses as well. So, which will improve the quality of air or the reduce the pollution definitely. So we can say as car sale is increasing, and as I with that also trucks, buses, other things are also increasing. So we will be requiring a large amount of charging system which will charge these vehicles. So with that we will come to our topic, which is charging system. We will say so large charging system infrastructure will be required. Now if you in India, if you see, there is one lagging factor, or we can say stopping factor for the growing electrical vehicle, is that the charging system, because still our charging system infrastructure has not yet developed yet. So if you take the vehicle and in case of Mumbai and all these things, if you see, people don't have the uh, park the vehicles. They are parking vehicles on the road, and if they are parking on the road, so how they will charge their vehicle? So you will require some proper electric vehicle charging systems or the infrastructure. Also, if you are going on the long drive, then you need in between the whatever charging systems. Even if you want to charge from the home, so there should be a proper system to have that charge. So these are the some means restricting or the stopping things to grow Indian market in electrical vehicle actually, and this also needs to be addressed parallelly, so that the growth of electrical vehicle will increase. So indirectly, we can say by addressing the infrastructure of electrical vehicle charging system, you are promoting to the electrical vehicle, which is promoting to the clean environment. So by to if you want to go for the again for the clean environment, then of course you have to increase the electrical vehicle, and which will be possible only if you increase the charging infrastructure. So what is the charging system? So the charging system is a set of components working to keep a charge and provide electrical energy for the vehicle electrical devices. So whatever vehicle electric devices are there, to charge that devices, the whatever components are there or whatever system is there, so that we can call it as a electrical vehicle charging system. For battery operated electric vehicle charging system, I say we require a DC charging voltage. But as we know, we have the AC. So from that AC, we have to convert that to the DC. Or if you have a DC source, which is like a PV or all that kind, then you can directly use that DC to charge the vehicle. So, uh, so vehicle from the common socket outlet or wireless. Here one terms I am using as a wireless because that is also one a charging system, and that is also a growing thing. So I have some slides on this also, wireless thing. So that also we will go through then. Now coming to the what are the battery charging systems? So one is the conductive charging system, which can be AC and DC. Conductive means directly we are taking the supply from the either from the grid or the DC, which will be directly connected to the battery through a wire or through a cable, we can say. So there is a direct connection. So that type of the charging system is called as the conductive charging system. It is directly conducting the power through the wire or the cables or whatever we can say, and it can be AC or the DC. The other is that inductive charging system. So this charging whatever system I am talking, this is purely in terms of considering a electrical vehicle and how you are transferring power from outside to the uh, to the vehicle actually. So if there is a direct connection from the source to the battery of the vehicle through the wire, then it is called as the conductive charging system. There is if there is no direct contact, you are using by some a wireless system, like a there is a wireless battery charge, a mobile charging system, where you cannot plug the cable into the your mobile. Only you will keep on the surface and it will get charged automatically by wireless. So that type of the system is called as the inductive charging system. And the next comes is the battery swap technology. So here, if you see, battery swap means directly what we are doing. The whatever battery pack is inside the vehicle is there, that will be removed, and the charge battery pack will be inserted in the vehicle. So in all the type, the source are the common. Either it will be grid or the PV or whatever it is there. But the how you are transferring that source power to the electric vehicle, so there are different type, and on that we have categorized as a different types of the battery charging system. Okay, so we can see again this system, uh, existence of this system, they can be categorized as a onboard or the offboard chargers. So if you are using one of the system of offboard means out of the vehicle, and onboard means inside the vehicle. So if you use the one of the system inside the vehicle, then it is called as the onboard. And if you use that one of the system outside the vehicle, it is called as the offboard. Okay. So did you get the terminologies? What are the battery charging system and what is the onboard chargers and offboard chargers? Because we are going to use this all the terminology in the next coming slides. I hope you got. Then, yeah. So onboard chargers are located within the vehicle, but there is a restriction of the size and power rating, because we cannot increase the weight or the size in the vehicle. So uh, or the space availability is also a constraint in that one. But in case of off-board, it can be a big one because it is a outboard. It is not directly placed inside the vehicle. So that is there is no restriction in case of the vehicle off-board charger actually. Okay, so we will see these three type one by one, and in that it can be off-board or the on-board. So depending on that, I will that also I will show you. but the major types are the conductive, uh, inductive, and the battery swap. And as I said, the conductive charging, so it is will be directly connection between the source to the electric vehicle, and electrical vehicle will have the battery which will store the energy. And this is the most common charging method right now. uh, Again, in this conductive charging there are two types: either it is AC or the DC charging. Now, what is the AC? So you can see this graph. So this is the AC source, or the grid, and there is a direct wire which will be connecting from this to here. And inside the vehicle, there will be a one charger. It is a onboard charger now. So that's why I explained the terminology in the previous slide. What is onboard and offboard, and depending on the type of the charging, it can be onboard or offboard or the mix. So you can see, for this charging system, what is the conductive charging AC. This is the source, and there will be the cable which will connect to the vehicle. And in vehicle there is a onboard charger which will convert this AC power to the DC to charge the battery. So that's it. This is the system of the AC. The advantages of having this AC charging system is the battery can be recharged anywhere, because this AC source will be available everywhere. So you can recharge every time. And the onboard EV charger. And the EV charger can be easily communicated with the battery management system. Battery management system is the one thing which is controls the battery actually. Charging of the battery, then heating of the battery, all that kind of the battery things will be taken care by the battery management system. And as whatever charger is there, so that is present on the vehicle itself, and the battery management system is also on the vehicle. So the communication between these two is easy, as compared to if you keep this charger outside, then the battery management system has to communicate with the outside charger. So compared to that, we have the easy communication between these two, and we do not require any additional power electronics outside the uh, outside the vehicle. So whatever it is there, it is the inside only. So this will leads higher performance and the lower cost as compared to the overall. But the disadvantages in terms of, if you see, so we have, as I said, there is a restriction of the space and whatever power electronics we are using. So because of that weight and space constraint, the power handling capacity of this will be a low. So it will be a slow charging. It cannot be a fast charging for the vehicle. Also, as it is a slow charging, so it will requires the longer time as compared to the other charging system. So the next obvious is that the conductive charging by the DC, and this will be mostly a offboard system, or the offboard charger is used, where there is a system which will convert the AC to a DC outside the vehicle, and that DC will be directly connected to the battery to charge the battery through the wire again, because it is a conductive charging. The advantages of this system is it can be designed with either a high or low charging rate. You can decide, depending on the power electronics you are using here, it can be high power or the low power to charge the battery. And it is, there is no restriction of weight and size because it is outside the vehicle. So that is the one advantages. DC charging with a high power requires a low charging time. So if you use the higher power charger here, so the battery will get charged in a very quick manner, and it will reduces the time. Okay. Then what are the disadvantages? In terms of disadvantages, if you see, the higher investment is required to install the this one. Then the high power demand on the grid is, means at the time, means this is the one issue which we needs to address now, as we are increasing the this offboard charger. So we are taking a lot of power from the grid and feeding to the battery, but at the peak hours, uh, peak hours, miss, I take it as a everyone knows already some basic terminologies of the power system and power electronics. But if you are not understanding anything, then just stop me here. 1 minute. Okay. So what is happening now, day by day, these charging systems are going increasing. So at peak hour, we are demanding a more power. So which will again make a adverse effect on the our grid system. So that is the one issue needs to be addressed now, and this is the one open point also to all you, or a research point we can say to all our colleagues. So that is one issue we can have with this type of the charging. uh, Also, the off-board chargers and BMS are physically separated, because your charger is here and BMS is here, which are physically separated. There should be a reliable communication between these two, otherwise it will affect overcharging of the battery, which may cause the uh, heating problem and that kind, or decreasing the life of the this battery. So that kind of the issues are there. So that is one thing where we have to concentrate when we are using the offboard chargers. Then uh, any as I said, you can stop anytime if you are not getting anything, or you can also tell me if I am going very fast or very slow. So if I want to increase speed, then also you can say, or going faster, then I can reduce the speed as well. I'm expecting at least some inputs from you guys. Don't be a only listener, be a participant. Okay. So battery charging system, then next charging system is the inductive charging. So in inductive charging is a wireless charging. So it is also called as a inductive charging system, and this will bring some advantages in terms of aesthetic. So it will be look wise and that kind of, it is a good quality. Then reliability, durability, and user friendliness. So these are the some advantages of the inductive charging. But there are many challenges in this type of the charging. One of the major challenges is the electromagnetic compatibility, because this will be placed at the means our residential places, and residential places, uh, if we are already designing the any electronics, power electronics devices, then we needs to comply with the EMC norms. So for complying that, whatever uh, inductive charging systems are there, they are very much difficult to comply that type. So, or we can, or indirectly we can say, it has the more issues with the EMCs as compared to the other charging system. Then till still we can say the whatever power transfer with that this type of the technology is limited to the low power. It's not high power, so the battery charging is slower. But this is also again a one research topic where you can have the more research to improve this problem actually, where you can improve the electromagnetic compatibility of the this type of the chargers, then power increase, and the efficiency is also one major issue in this type kind. So that is also one you can have the research in that area also. Other than this, it is a bulky, then expensive, and shorter range, because of the um, we cannot have the uh, vehicle is kept somewhat else, and your charging point is at the one. There needs a very close uh, distance between the charging point and the vehicle. So that are the some uh, what we can say uh, s- still research topics for the this type of the charging system. Again, in this also there are two types in inductive charging. One is the static charging. Static charging means the charging at the when the vehicle is as the static or the at the rest position. So what will happen? Vehicle will go on the top of or the in front of the charging wireless charging point, and one transmitter will be somewhere on the ground or the at the wall, and receiver will be in the vehicle, and the power will be transferred from this transmitter to the receiver. Advantages of this will be it is a convenient and suitable for the self-driving cars. Disadvantages is the high investment, so this will require the high investment, limited space and weight of the charge pads. So you have the limitation on the space and weight of the charge pads. This because again charge pad means a transmitter we can say, and if you see it will be requiring a very good alignment between the this transmitter and receiver actually. If there is a mismatch in this alignment, then it will affect on the power transfer in terms of efficiency. So that is one also. uh, it is not a power electronics research area, but this is also a one research area, the alignment of vehicle to the this one actually. Okay, then as I said, it has a relatively lower efficiency than the conductive charging and the electromagnetic radiation. Then other type is the in terms of in inductive charging is the dynamic charging. So dynamic charging means vehicle is dynamic or it is in the running condition. So in this case, the transmitter are mounted on the road itself, and vehicle has the receiver. So while moving the vehicle, it will take the power from the this transmitter. So it will keep on transmitting power, and whenever this receiver comes, the power will be collected. So this is the one concept. So advantages of this concept is the low standing charging time, means you should not wait to get the your vehicle charge. While running itself, you can charge your vehicle. Then low battery depth of discharge. Uh, Depth of discharge actually. Okay, yeah. So this depth of discharge is the concept where uh, it is opposite of state of charge of the battery. So state of the charge is the how much battery has charge or the power is measured in terms of SOC. And depth of charge is means how much power you have used or how much discharge you have discharged already is a DOD. So in this case, as it is continuously getting charged, you are not discharging much battery as compared to the in normal operation. In normal, what we are doing, we are charging to the full and then trying to discharge to the its maximum capacity. But here continuously as charging, so DOD will be lower. And how it will be useful, if you see, this is the graph you can see. If you are not discharging the your battery to a its 80% or the more than that, then you can increase your the battery life cycle actually. So every time, if you take the example of the your mobile, and you charge to the 100%, and you will discharge up to 20% only, and again charge to the 100, and again use up to discharge 20% means use up to 80% of your battery capacity. So every time if you do that kind, so your battery life cycle will increase. But if you charge battery 100%, and you will go to the almost 80% means your battery will be only remains SOC will be 20%. In that case, so your battery life cycle will decrease. So that is the advantages if if you have this kind of the system actually. Okay. And of course, as we are using the continuous charging, there is no need to store more energy here. So smaller batteries can be used, which will drive the this one. But the disadvantages, if you see, it is whatever power transmission is there, so the through over the whole range of road actually. So it should be on kilometers, hundreds of kilometers. You have to implement that one.
So anywhere right now it has been installed.
Uh, Here I have in red one statement you can read.
Okay.
It's still in the experiment stage.
Okay. 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 So
Many challenges are there which needs to be standardized actually. But some what we can say experiments are going on this kind actually. But of course, it is a very high cost investment. Then coil misalignment and that kind of uh, uh, st- problems, or we can say challenges are there. Also there is a major challenge is that different car will have the different coils, and there should be the universal system which will be fit to the all the vehicles, so everyone has to follow that one. Then only it makes sense to have that system on the roads. So that kind of challenges are there. So this type of the still in experiment, and of course some prototypes are built and they are in the testing mode. Okay, the last one, we can say the battery swap. So as name suggests, so here we can see whenever there is a discharge of battery, so it will be taken out, it will be charged, and it will be replaced with a fully charged. But when you go for the this station of the this battery swap, directly this will be taken out and charge battery will be inserted and you can go out. So it is a very fast process. So here I am written the same thing, the word switching out the depleted battery and the replacing the same with the full battery. Uh, so the process involves driving into the battery switching bay, and automated process will be position the vehicle, switch out the current battery, replace with the fully charged battery, and insert the uh, or they take out the battery which is drained, and this will get charged in the that station actually to keep the battery ready to the next vehicle. So advantages of this is the no range limitation, because now if you see the vehicle range will depends on the your battery capacity. So battery is larger, then your vehicle range is larger. Battery is smaller means your vehicle range is smaller. But no such thing. Here you can use the smaller battery or the larger battery, it will not limit your range, because it can be replaced directly from the other battery once it get drained. Then the quick and easy refill, like a combustion engines, or we can say whatever we are doing the for the petrol and diesel refilling. So that kind of the process only it is there. So longer charging times available for the EV battery compared to the fast DC charging. So here the charging is happening at the bay where there is no restriction of the time. So you can charge in a longer time as well by using a efficient way, and also uh, as you are not charging a very fast, so it will not affect your life of the battery also. So challenges in this method again, standardization is the major challenge, because this battery, whatever battery is going in and out, so they for all vehicles it should be same. Otherwise, if your space or connector or that kind and all these things is if it is changing, even rating is changing, then you cannot have the same battery setup for the all the vehicles. It needs to be standardized. So that is one major challenge. Then the consumer acceptance of not moving a battery, and having to the change of vehicle battery. So this is also one major concern in India also, we can say, because when our Indian mentality is that whenever it's our own, then we will take care very seriously. But if it is public or someone else, or we are renting, then we will not take care as that as we are taking care of our. So here the battery will be owned by the someone else, and you are renting it, or it is taking by for the some time. So this is the some others property we will behave. And so there we can say consumer acceptance, or the how you are accepting or how you are using it. So that is also one major challenge in this kind of the technology actually. Okay, with this charging system, then uh, we should I have highlighted here some basics of the battery also. So we said that of course we need to charge the battery either from various type, either from the battery swapping or the inductive charging or the conductive charging. But what is the battery, or the what type of the battery is used for the electric vehicle? So broadly, if you classified all type of the batteries, they are classified into three categories. One is the primary batteries, so which converts the chemical energy to the electrical energy, and it will not again convert the electrical energy to the chemical energy. So this is the we can say use and throw battery kind of thing we are calling it as. And we are using in our daily uses like a double A or triple A batteries in the toys and remotes and that kind. So this that type of the battery comes in the category as a primary batteries, which which converts the electrical energy to the sorry, chemical energy to the electrical energy only. And other categories the secondary batteries, which are the rechargeable. So here the batteries are capable to convert the chemical energy to the electrical energy, and when you apply the electrical energy, then again they can convert that to the electrical chemical energy. So they are rechargeable batteries, and the same that kind of the batteries are used in the electrical vehicle. So same batteries that kind we are using in the mobile phone as well, EVs, and some other portable electronics also. One more type of battery is there, that is the reserve battery. So reserve battery has a one special characteristics is that when you keep that battery aside, so it will remains charged for a longer time. There is very less self discharging. If you see every batteries has the if you keep charge battery as it has lifetime. It will get discharged over the time actually, means it is getting self discharging. So that phenomena is very low in reserve batteries. And this kind of batteries are used in some special application like a missile projectiles. So where you will keep the equipment for a longer time, and whenever there is a need like a war and that kind, that time only you are triggering. So if we not use that kind of batteries there, then when once war started, then we have to go first for the battery charging, then we have to go to the war. So in that so such applications, there is a special type of the battery which will keep the charge to a longer time, and its self discharging is very low. So that is also one battery, but we are more focused on the secondary batteries which we are using in the electrical vehicles. Now in electrical vehicles again, how the battery pack will be there, or the we will call it as a battery pack, but it is not a single cell or the single thing. So how it is made up of? Actually, most of the modern cars are using lithium batteries. Okay, and each lithium battery cell will have the 3.7 volt per cell. And if you see the car or anything, we will be requiring around the 300 volt. So how it will be achieved? To achieve this one means many cells will be combined in series and parallel to form a module. So this type of the cells are connected in the series and parallel to have a one module actually. So you can see this is the one module. Then these module along with some protection circuitry which is called as the battery management system and cooling system are arranged in a mechanical casing collectively called as the battery pack. So this type of the module again we will arrange here in, they are again arranging in the series as well as the parallel, but with some protection like a battery management system, then cooling system in a mechanical point. So whole this thing will be called as a battery pack, and this will be used for the uh, our cars or any electrical vehicle. So this is the general structure of the any battery pack. Okay. Then coming to how this battery will be get charged, or this whatever cells or batteries are there. So how they are getting charged? So there are three. We are charging that from the electrical vehicle charging system, but how they are getting charged or what control we are using to charge the battery? So there are three types. One is the constant voltage. So here we are directly applying a constant voltage to the battery and it is getting charged. Then the constant current, where we are using a constant or controlled current to charge the battery, and the combination of these two, which is the constant current and constant voltage. Now in constant voltage, as I said, it will allow the full current to charge. Here only voltage will be controlled and it will be set a whatever battery voltage is there, and it will charge with that voltage. So it will take the full current to charge and it will go to the predefined voltage. Then current as means it will get charged, the battery voltage increases, and whatever voltage you have applied and the battery voltage, the difference will reduces, and as the difference reduces your current will come down and it will reaches to its maximum value. In constant current mode, what we are doing, irrespective of the battery voltage, we are trying to charge the battery with a constant current. So whatever charging current requirement is there, that full current will be used to charge the battery. So continuously it will be given to the battery, but here there are some disadvantages that it can overheat the uh, battery, and it will damage the battery. This type of the technology is only used for the NIMH type batteries, and in this also there is a special uh, uh, care has to be taken, like you have to disconnect the battery once it gets charged, otherwise it will get the overheated. So most commonly used charging technology is the constant voltage constant current. So it is a combination of the two. So lead acid and all that kind of the batteries are charged with this type. So here we will charge in the constant current mode at start and the constant voltage in the uh, afterwards. I will come to this, yes, in this graph so you can understand more clearly. So you can see first battery will get charged with a constant current. So that time voltage, if you see, as the if battery is in discharge mode, so the voltage is very low. As you start the charging battery from here, so it will start the increasing the voltage, battery voltage. Now here it is reached to the maximum battery voltage. Now here onwards, if you want to keep the same current, then whatever voltage has to be there, so that has to be applied higher, because you know the current, whatever current flow, it will depends on the voltage difference, potential difference. So if you want to drive the more current, then the one potential difference has to be increased as the battery voltage increases, but that will damage the battery. So here we cannot increase the voltage beyond this. We have to stick to that voltage. So here the voltage has kept constant for the charging. So what will happen? The difference between the battery voltage and the you applied voltage has reduced. So the current will get reduces here. So this is the charging cycle, and this is the safest charging cycle for the any of the battery actually. First, you have to charge with a constant current uh, till it will reaches to its maximum voltage, and once it get maximum voltage, you have to keep the voltage to that voltage level, so current will decreases. So you can see in terms of charge, this is the charge graph. So the maximum charge is getting in this area, and from this to this it is taking longer time. And the percentage wise, if you see here, the almost 70% got charged very fast, and remaining 30% is taking more time actually. Okay, then so same thing I have written here. So battery charging is broken down into two distinct phases: constant current and constant voltage. The charger limits the amount of current preset level. So this is the set value, and once it reaches to pre-voltage, then the current reduces, and this is the actual charging way. Now, as per the now we understood why we require the charging system. Then, what are the types of the charging system, and how the charging system will charge the battery, and what are the battery kind. Now, after all these things, now we will move to a topic of actual vehicle charging systems. So where there are some range or the norms have defined to charge the battery for the all the electric vehicle. This is done because see they means anyone can use the anything, but if you won't standardize something, then it will be difficult to everyone to means I have a suppose a charging system. So for on my charging system, the Mahindra will come, then Tata will come, also MG will come to charge the vehicle. But if you don't have any standard way of charging, then I need the different charger for the Tata, different charger for the MG, different charger for the Mahindra. So to avoid all that kind, so there is a standards which we have to follow while the charging the this electrical vehicle. But unfortunately, there is no common standard available now. There are different standards available, and still means uh, three, four standards at least are there, which are in the market, and the vehicles and the charging systems are developed according to these standards. We'll come to that standards also. Before that, in the charging system, uh, as per the JE, this standard, three levels have defined. So one level is defined to define the power range actually, power range or the voltage range. So that kind. There is a charging levels and charging modes actually. Levels in terms of we can say voltages and power rating, and the modes in terms of how the protection devices are used or the communication devices are used. So in that manner, modes have defined, and levels have defined in terms of the voltages and the power rating. So you should differentiate between the level and the modes actually. So here the levels have defined. So level 1, level 2, level 3. In level 1, the voltage range is 120 volt, single phase AC voltage, and ampere rating is the 12 to 16 ampere, and charging power is 1.4 to 1.9. So with this charging, we can have the 3 to 5 miles of the range if you charge by for the 1 hour actually. So which is very slow charging system, we can say. Then the next is the AC level 2, which is this is used in the majorly US. So if you know that US has the 120 single phase system as well, where we have the 240 volt or the 208 volt. So this is our system where we have the single phase system, and the current rating for this level 2 is 12 to 80 ampere, typical 32, and the power range is 2.5 to 19.2 kilowatt, and range is we can drive the 10 to 20 miles of vehicle per hour if we charge for the 1 hour. Next is the level 3, which is the DC charge. So in DC charge, the range is either 208 volt. Again, this is the US three phase AC, and the 480 volt. This is ours. Up to 28 to 480 it is there. So we have the 400 or 415 AC system. The current rating can be up to 125 ampere. Now this has increased actually. So previously it is was up to 90 kilowatt, but now it has increased up to 300 kilowatt as well. So this is the one. So 80% charge can be achieved in 20 to 30 minutes actually with this type of the thing. So these are the levels. Then, as I said, coming to the modes, there are different modes. So this will be differentiated in terms of how the protection things you are using, protection or the communication. So in mode one, which is a very simplest mode, it is called as the also called as Kudo mode, and it is directly connected to the household. So there is no protection inside the wire or anything. So we can say there will be a fuses to our system, but which are very slow. So there is anything happens, so there is a very unsafe condition in this case. So which is not recommended, and it comes in the mode one. So we can say it is a forbidden in many parts of the world, but yet it is in the use in some part of the Europe. Next comes is the mode 2. It is a similar to mode 1. Difference is that here there is a protection devices which is called as the uh, protective protective device inserted in the cable. So the cable has some protective devices which will take care of the heating and inrush and that kind. So that type of the mode is called as the mode 2. Still it is a AC charging in mode 2 also. And in cable there is a control protection. So that is the mode 2. Its limit is 3.7 kilowatt and 16 ampere. In mode 3, uh, still it is a AC charging only, but here whatever system it is there, it has all the protection, and also it has the communication to communicate with the vehicle. Why we require this communication again? Because we are giving the more power and battery, and that kind of the communication has to be done through this one, also the protection point of view. So here uh, it has the system which will incorporate all that kind of control and communication and protection functionality, and it will charge the vehicle through the AC only. So this has the wide range up to 3.7 to 43 kilowatt, uh, and this comes in the mode 3. Here it is given the 43, but generally it will be used between the 3.8 to 22 kilowatt. And last one is the DC charging, which will come in the mode 4. So again, mode 4, it will have the uh, off-board charger. So here can be onboard charger will be bypass and only charge via this one. As it is outside, so there is no power limitation. So we can have the higher power also, or 150 kilowatt as well. and again whatever communication and protections are there, so that will be uh, placed in the this charger. And for the communication, again here they have written there are some standards which will be we will come in the next slides. So you understood the difference between the levels and the modes. So the levels are the depending on the what voltage range and the power you are using, and the modes in terms of the protection and the communication point of view. Okay. Now coming to this overall charging system configuration, or in terms of power electronics, how it will be there. So you can see in this picture you can see the off board as well as the on board charger. So this is the onboard charger. You can say this is the highlighted part, or the colored part is the onboard charger, and this is the off-board charger. In onboard charger, what will be there? As I said, in onboard charger, it will take the AC power, okay, and that will be converted to the DC by using some rectifier or anything, and that DC again will be given to the DC-DC converter, which will charge the battery. Why we require this DC-DC controller? Because battery, as we just discuss how the battery will be charged, it will be charged first constant current and the constant voltage. So you will be requiring a constant or the controlled DC here to charge the battery. So there we will be using the to control the DC, we will be using the DC-DC converter. So this is the inside the onboard only. And in offboard, if you see again here it will be AC to DC and the DC-DC converter, which will be directly charging the battery here. Here also we'll be requiring the DC-DC to have the control this one DC. And as a vehicle, if you see with this is the charging of the battery, this battery. Now this battery has to supply to the motor. So again, it will go through either directly through the DC-DC and the DC-AC, or in some cases it will be directly have the DC to AC directly, which will drive the electric motor. Also, there is one more DC-DC converter which will be called as a auxiliary, and which will supplies the auxiliary things like a your all control of the vehicle, then the lightning of the vehicle. So whatever are electronics you are using in the vehicle, so that will require again power, which will have a one more DC-DC converter. So this is the overall configuration for the any vehicle nowadays have in this way. So if it is a onboard charging, then how it will be there? So there will be either level 1 or level 2 type of the charging system. Then it will be connected to the fixed AC supply, uh, or we can say this is the level 1, level 2, and with a fixed AC supply, which will gives to the rectifier inside the vehicle. So this will be the outside, either level 1 or level 2, and uh, this will be giving to the rectifier, which will convert to the DC, and DC-DC converter will use the variable DC to charge the battery through a protective circuit. And to control all the protection and battery charging, there will be the BMS system, which will take the feedbacks from the battery and give the inputs to the protection device or the control device. So this is the overall we can say onboard charging with a level 1 and level 2. For the level 3, as I said, all this thing will be outside, or so you can say here you will get the from the AC itself, you will get the variable DC by having the AC to DC and DC-DC converters here, and which will be directly feeding to the battery through the protective circuit. Again here BMS will be there, which will communicate to the protection circuit inside the vehicle, and also to the uh, power electronics or the controller of the power electronics, which is the outside the vehicle, which is the upboard only. So that communication is required. Okay. So what are the advantages to having the onboard charge? So if you see onboard charge, if we have the battery charges are limited, uh, advantages or we can say disadvantages also. So we have the limitation of size and weight if you want to go for the onboard charger, and so they will compatible with the level 1 and level 2 because of the power level. We cannot have the higher power level. Then they usually have the unidirectional power transfer capability. So onboard charger, whatever existing are there, they are more focusing on the unidirectional because of two things. Uh, mm, we don't want to transfer the power from the vehicle to outside, so there is no need to reverse direction, and it will save the cost. But there is a concept called as the vehicle to grid, which will transfer the power from the vehicle to grid. So in that case, we need say bidirectional thing, and that is also in uh, in we can say research phase actually. Then onboard chargers are typically composed of two stages: a front end AC to DC stage and the back end DC-DC stage. And for this, there are various topologies that use. So one of thing I have shown here how it will be power electronics will be there inside the uh, vehicle. So when the power comes, there will be the EMI EMC filter which will feed to the rectifier, which will convert the AC to the DC. This EMI filter will be used to uh, restrict the whatever EMI EMC will be conducted or emitted from the this circuitry. So this will be placed at the input, and this will convert to the DC. Then DC, there will be a power factor correction to get the unity power factor. So we can use the either boost or other technology to have the power factor correction here, and that will be given to the DC-DC converter, which will have the isolation here. So there is a basic requirement in terms of safety is that whatever battery, so battery power is there or and the grid power is there, they should be galvanically isolated. There should be somewhere isolation between the this path. So it can be at the input side. So here you can directly give the transformer here so that you will get the isolation here itself, and here then there is no need of the isolated converter here. But the disadvantages of having the isolation here is that so this transformer will be operating at the 50 hertz. So as you know, the magnetics is inversely proportional to the frequency size of the magnetics. So as the frequency is lower, the size is very bulky. So you will be requiring a bulky transformer. But here what we are doing, this we are operating at a higher frequency. So we are using the high frequency transformer, which will reduces the size and all that time, and you will get the more beneficial in terms of this one. So generally, the isolation transformer will be used here to have the isolation between the grid and the battery. So this is one unidirectional, you can say DC-DC converter, which will convert the uh, DC here. So by seeing this, if anyone recognize this, which kind of topology is there? So is anyone able to recognize this topology? So you can see here it is used the L and C. So this is the LLC converter topology. Also it can be phase shifted also. So some of the topologies I have discussed in coming slides as well. but I think I am going very slow. Uh, let's see. Uh, if you don't mind, some of the slides now I will start skipping so that we will be in time. Is it okay?
Yes, yes, yes.
Fine, fine, sir. You
I'm
can
fine.
proceed.
Yeah.
We have 10 or 15 minutes more.
At least you give me 30 minutes. Okay, okay. So we have to discuss the question answers also.
Yeah, 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 yeah. Actually, no problem. You can take your time, but then discussions will be taking time, right? So
Yeah, yeah, yeah.
at least
Okay,
10 minutes for discussion. So 15
okay,
minutes.
okay, okay,
Okay,
okay,
okay, okay.
okay. Then, okay. So the onboard charges can be unidirectional and bidirectional, as I said. And this bidirectional will be mainly requiring when you want a V2G, that is the vehicle to grid. Generally, if you want to transfer power from the grid to vehicles, it can be unidirectional. But if you want to both direction, grid to vehicle as well, then it will be the bidirectional one. Again, in this either unidirectional or bidirectional, it can be two stage, means there will be two stages, one to convert from AC to DC and DC to DC. So these two stages, or the single stage where it can convert directly AC to the variable DC which is required by the battery. So that is also one kind, or the one type we can say. And it can be unidirectional or bidirectional as well for the two stage as well as the single stage. Then the multifunctional means it will incorporate the other sources also, like a battery with a PV and that kind. So in that type we can say it is a multifunction. So these are the some types or the general topologies used for the uh, our onboard chargers. So one is the full bridge rectifier with the conventional power factor connection boost converter, which I have shown in the previous figures as well. Full bridge rectifier with the interleaved power factor boost converters. Then the full bridge LLC converter. Uh, Sorry, here I have written the wrong. It is not a full bridge; it is a half bridge LLC resonant converter. Then coming to this one, this is the full bridge LLC resonant converter, which again we have used in the previous figure. And it can be a phase shifted full bridge converter. So difference between these two is that here we are using the resonant tank, which will gives the you can see soft switching of the converter. So it can here you, for this you will get the constant voltage switching, and here sorry zero voltage switching, and for these devices you will get the zero current switching. In terms of phase shifted, so the power transfer will be controlled by controlling the phase difference between these two legs, okay, by switching these two. And power transfer will be controlled according to that, but here you can get the zero voltage switching for this primary switches, but you cannot get the zero current switching for this one. But if you compare this to the control point of view, this is very simple, and this has some complication, because here the to control the power we have to control the frequency, whereas here we have to control only phase difference between these two legs. This is one more topology where phase shift is there, but with some center tap rectifier stage. So these are the some different topologies which we are using for the onboard charges. So the major challenge is here is the size and the efficiency which we are getting. So we need to get a small size, higher efficiency, and so that kind of the challenges we have to tackle here. Then in onboard charger again, if we see the multifunctionality, what I say, so it can be linked with some of the battery. Then it is called as the multifunctional. Then here it is a integrated bidirectional power converter. So it is a bidirectional which can convert from or the flow of power from one direction to the other direction. And similarly here, this is the single example of a single stage AC to DC converter for the battery charger. There is no separate AC to DC and DC DC converter. It is a single stage converter. So I will skip this because you can by some of most of the points we have covered. What are the advantages of the onboard and what are the advantages of the offboard? So this I can skip. When so most we already covered the onboard charging. Then the if we see the offboard charging as already discussed, so it will give the more advantages uh, uh, in terms of the space and that kind of. So we can charge very fast, but as I touch the point, we needs to proper communication between the vehicle and the battery. Vehicle and the charging system to have the exact battery management. And also if you see uh, when you are charging from the outside, so the chargers will not be owned by the electrical vehicle owner. So we need say some billing system and some other communication, some protection. So that kind of things will come when you go for the offboard charging system. So overall offboard charging, if you see, there will be a power electronics which will have the uh, input side some protection filters, and the AC to DC converter, then DC DC converter, and this will go to the electric vehicle. But along with that, there will be the controllers which will control this system, also the communication system which will show here whatever you are powering or whatever billing and that kind. And also it will require say some uh, uh, misconnection with the cloud and phones to get the more accessibility to charger points actually. So this is the overall system now for the outboard. So as I said, to standardize to the different vehicle and different charging system, uh, there are some charging standards have developed, and they define what kind of socket will be there, then what communication will be there, and how the pattern of the communication between the battery and vehicle. So one example, if take if I say one vehicle have the battery of 300 volt and other vehicle has the battery of a 200 volt only. But if we want to charge from the same battery from the charging system, then there should be the communication between these two. So what is the battery range, what is the power range, and how that will be this thing charge and discharge. So that communication is required when vehicle goes to the any charging system. And for that many standards developed. One standard is the GB by T, which is mainly used in the China. Then other one is the CHAdeMO, which is used by the Japanese vehicles mostly, and some European vehicles as well. Then the other one is the CCS. CCS 1 and 2 are there actually, which are used in the US and the Europe. India has adapted the CHAdeMO and CCS2 both actually. Previously, they were going towards the GBYT, but finally they decided to go for the CHAdeMO and CCS2 combined. So in India, whatever chargers will come, they will have the CHAdeMO and CCS2, and vehicle has to comply these two systems actually, either CHAdeMO or the CCS2. Then Tesla actually they built their own vehicle as well as their own charging system actually. So they have not in other cases what is happening, vehicle is owned by the other manufacturer and the charging system by owned by the other manufacturer, and the owner of the vehicle as well as the charging system also different. So there needs some standard or a common standards. But for Tesla, what happened, they owned their own charging system as well as the vehicle. So they developed their own charging system called as a Tesla system, and they are using that one. Now this is one proposed which is combined of all the this charging system which is in still in proposed stage, and this will combine all this thing, and you will have a one common platform to charge the all the vehicles. Okay, so they have a difference in terms of the power as well as the communication type and where they have used. So here you can see previously it was in India, but now India is no longer using this GB by T. We have shifted to the CHAdeMO and CCS2 actually. I have many more, but okay. So this is the combined charging system. I will share the slides so you can go through it to get the more details of this one. Okay, so this is the combined overall charging system which will have, if you see the cable, so this is the cable actually, which will have the main cables, which is for the power transfer, DC plus and DC minus. Along with there will be the communication and some protection things will be go through the wire to communicate between the your charging system and the electrical vehicle. So this is for the combined charging system, that is the CCS standard. And in CHAdeMO standards also, so it is there. So there is a how it is there. So depending on the standard, the communication way and the protection ways are different for the both. Then, as I said, one proposed standard which is called as the HPCVC or the megawatt standard, which will combine all the standard. Also, it will increase the range. Currently, the range is up to 1,000 volt, 500 ampere for the any system, but now it will go to the 1,500 volt to and 3,000 ampere, which is in proposed mode actually. And this was proposed by the CCS team, CCS standards team, which is called as the Charlene Charlene team actually. So they are proposed this one, but CHAdeMO also proposed the in similar manner, and they are combining with the GB by T, called as the ChowG standard, and they are also thinking to take the CCS also in their standard and make a combined one. But still, these are in the proposal. But who will win? Let's see. So the time will give the answer of this one. But at least currently, we can say in China, GB by T is there, and Japanese and most of the things CHAdeMOs are used, and in US and European CCS is used, and in India CHAdeMO and CCS are used. Okay. So one more, as I said, this is the megawatt charging or the high power chargings are coming. So there also one concept is that we can charge the many vehicles parallelly from the one charging system itself. So for that, again, there are some standard requirement how you can have the system. Either you will have the common AC to DC and the multi DC AC and AC DC, that is the DC DC, or the common DC DC. So that kind of things are there. That also I will skip. And yeah, as I said, overall we will be requiring the isolation. So either we can keep the isolation between the DC-DC converter. So this is a complete DC-DC converter which can see, which will convert the DC to the high AC and isolation and high AC to DC. So this is the isolated DC-DC converter. So either you can have the isolation here or here. So the same will applies to the multi-charging ports as well. Either you can separately give the isolation here or combined isolation and then one common AC to DC, and you will have the non-isolated DC-DC converters. So more commonly used AC to DC systems are the two-level converter, which is also called as a three-phase VSC converter. So which is a common three-phase converter, we can say, which we are using. Also, in many some application, three-level NPC converter is also used. So it has some advantages, but as the number of devices increases, then cost will increase. This is a unidirectional called as the VNR rectifier. So advantages of this is there. If you see, there are very less control devices, and others are the diodes, which will benefits in terms of the control and the cost point of view, because diodes will be very low cost as compared to the switches, and also will not require any gate driver circuitry and that kind. So this is again one more type is the neutral point clamp converter, which is also commonly used. Then Vienna 6 switch rectifier. So here we are using the 6 switches instead of 3 switches in the previous case. This is the 3 switch case. Also, it can be Vienna T type rectifier, Vienna Y switch rectifier, Vienna delta switch connection. But whatever Vienna I have, all these are, or this neutral point also is a unidirectional one. So overall, if you see any converter, then it will have the from the AC side, you will have the uh, some protection devices, and also the to sense the voltage sensing will be required, and then the current sensing, then the filters, EMI EMC filters, again here the current sensors, and the switching for switching that gate driver, and the output switching. So this is the overall power electronic system we will have for the any converter, and there will be the controller which will either sense the supplies and give the signal to the control the devices. Then for the DC-DC part, it can be, as I said, non-isolated or the isolated. If you have the isolation at the AC side, so it will be non-isolated DC-DC converter. And if you have the isolation at the middle, then it will be uh, uh, isolated DC-DC. So in um, non-isolated, mostly the interleaved buck converters are used. Then for the isolation, as I said, LLC, where you will get the isolation here, high frequency transformer, and this is the phase shifted, and these are the some unidirectional and bidirectional isolated converters. So this is the half bridge, this is the full bridge, then three phase configuration. Similarly, for the bidirectional half bridge DAB, this is the dual active bridge, where you will have the switches on the both side which control the power in both the direction. Full bridge DAB, three phase DAB. And these are the some example of overall systems used for the offboard charger. And offboard charging, okay, I will skip this also. And new trend is coming to use of SiC switches, all the devices. SiC switches is the has the advantages that it has the lower conduction and switching losses, so which will reduce the losses and the footprint, and it will also, as the efficiency increases, so it will save the your energy. uh, I will not touch now V2G technology, so just give the brief. V2G, as I said, it will be a vehicle to grid. So this is the overall advantages is that whenever there is a peak load, we can take the power from the vehicle and balance it. So the battery, it will be used to balance your grid, overall grid. Also, it can be a different type, like a V2L, means vehicle to load, where we can use it as a for the some isolated load like a camping and that kind of loads, where we will take the power from the directly from the vehicle and use it. Or we can give it to the home, it is called as V2H, or the building, similar to the home but for the building, and also directly to the grid. And one point which is one type of the wireless charging. So in wireless charging, how it will be there? So you will have the source with a EMI filter, then power factor connection, then the DC to AC converter, and here you will have the coils, and before that you will require the power primary compensation network. So this compensation is network is mainly required to fulfill the reactive power requirement of the this converter, because this is a overall an inductive principle. So we require a compensation network on the both the side to have the this wireless transfer actually, and this will be fitting in the vehicle, and this will be the outside the vehicle. Yeah, one point just I wanted to just touch, because this is one miss. If you see, this slide is also not completed, because this is the one major topic now we have to address, is the impact of the electric vehicles on the grid. So there are some positive impacts, like by using V2G we can balance the grid and that kind, but there are many adverse impact, like a voltage instability, as we are directly taking high power from the grid now, so it will affect. And that also increase if you are start the charging many vehicles at the same time, then it will increase the peak demand actually. Also, as everything is using the power electronics, and whenever power electronics comes or it will be attached to the power grid, then there is a issue of power quality, so which needs to be addressed. Then increase power losses and transformer heating because of this harmonics and that kind. So all these are means some of the points which I have listed for the impacts on the grid, and which are the uh, research topic we can say needs to work on these topics. Um, till now we are not getting any of the problem in India, but in coming days definitely we will face these problems because of the increase in the this electrical vehicle and the charging infrastructure. So this my slide is also incomplete, because this is a research topic and we have to work in this area. Uh, so you can go through it. These are the some references I have referred for the my this presentation. Thank you. Sorry if last 15 minutes or 23 minutes I was very fast, but
No, no, no problem, no problem. So now I will open this session for the participants to ask any doubts regarding to the session, or if you want to discuss anything with the speaker, you can please unmute yourself and ask.
yes,
Okay, I think, okay, so I have one doubt.
yes.
So you have shown in one of your slides that 300 kilowatt charging is done. So,
Hmm.
what is the voltage level for that? I think 1000 volt.
See, cars, whatever cars are there, they are still coming below 500 volt. Okay,
Okay.
but now the trucks and buses are there, which will have the more battery pack. So they are
Hmm.
coming around the range of 750 to 800 volt.
Okay.
But as I said, one standard also coming, which will be go to the 1500, and as per that standard, miss this 1500 I said in terms of charging system. But charging system will be required when the vehicle also go to that voltage, then only uh, miss that will be required. So as per that standard, there are some developments are going on the vehicle side, mainly for the again for the trucks and buses. till 1250 battery voltage.
1250 watt voltage. So at
Yes.
that voltage level, what will be the topology that is preferred, or that will be preferred, or they are working on something new to bring up?
No, in topology point of view, see, what is the challenge in the topology point of view? Actually, I forgot to mention this point. Thanks, you have asked this question. When you have the charging system, so that time you are not tackling only high voltage means vehicles, or the only not low voltage vehicles. You have to tackle all kind of vehicles. So what is happening at the lower voltage? If I say I have the 50 kilowatt of battery charging system, okay, then my if you are want to charge with a only a 100 volt, then you will be requiring 500 ampere of current. But if you are going to the 500 volt, you will be requiring only 100 ampere of current. So what is happening at low voltages? You will be requiring the higher current, your charger or your
Right,
power electronic system,
right,
and for the higher voltages, you will be requiring the lower current,
correct,
and that has to be taken care by a single power electronics system actually, which is the challenge.
right.
So in this case, one option is that you have to go for the say parallel connection at the lower voltages. You
Parallel
will
connection
get,
of series.
yeah, I mean, whatever output rectifier on the DC-DC side, if you see after the isolation, there is a diode rectifiers. So that you can parallel at the lower voltages. Okay, and
Mhm.
when the voltage is higher, then you can make it in series. So there your current rating will reduce, but the voltage rating has increased. And for the lower voltages, as they are in parallel, you will get the higher current, but the lower voltages, whatever switches you have used. So that kind of the advantages or this thing optimization is required in the system to tackle the whole wider range of the vehicle charging systems. Actually,
Okay, okay. So parallel and series will be connected through a relay.
yes.
Okay, okay,
So once vehicle comes, it will start the communicating with that what is the battery voltage range and that kind. So as per that, you make the power electronics arrangement such that either in series or parallel, which you will be requiring, and you will be ready to that range. Then you start the charging.
okay, okay, okay. And one more doubt I'm having, which is not in the today's session, but regarding the inverter that is between the battery and the motor. So what is that trend going on? Because right now it is 600 volt, I think. So it is moving up towards 800, or all the performance or are met at 600 volt level.
Uh, uh, if you see in terms of motor, so motor voltage is not increasing much. So there we are trying to have the same voltage, but more power density kind of thing actually. So in
Right.
terms of maybe I am not everything I am not
Okay.
knowing in
Right.
that area,
Right.
but
Right. Right.
whatever I have that knowledge. So the uh, in miss motor point of view, still the voltages and that kind of have not increased. The voltage has increased to store
Power.
more power with a lower current, charging current in the battery packs actually. So
Okay.
for that reason only the voltages level have increased, not to increase the motor we can say voltage.
Mm-hmm. Right. Right.
But of course, if you are taking the power from the that higher voltage battery to the even to the same AC voltage motor, you needs to change accordingly because
Mhm.
at least input has changed now.
Changed. Right.
Yeah.
Okay. Any more? Any queries from the participants?
Either you understood everything or many thing went from
One.
your head.
One has. posted.
Okay.
So that's an excellent presentation. Even my research area is different domain. Grasped a lot of knowledge about EV charging system. Thank you so much, sir.
Thank you.
Okay, okay. So we will conclude the session. Can I share my slide screen?
Yes, please.
Okay, okay. One doubt participant has asked.
Yeah. Okay.
I joined late. How do you manage a constant current of constant voltage 300 kilowatt system?
Uh, so the answer is again, we have the DC-DC converter. So where the DC-DC converter will the reference will be given to that DC-DC converter. What will be the output current first when it is operating in the constant current mode? So according to that, it will adjust the voltage to send that much current only, fixed current, whatever current. So once when it is in constant current mode. So again, that will how that constant current is achieved depends on the topology. If you are using the say LLC topology, then it will be controlled by controlling the frequency. And if you are using the phase shifted full bridge, then you are controlling that by using the phase shifting of that one.
So ultimately,
And
we are controlling the voltage to maintain the constant current.
yes, every time if you see any converter, what we are doing in terms of if you want to control the current as well, means what you are controlling the potential difference between the receiving end and the sending end.
Correct.
So that voltage has to be maintained actually, or controlled, so that that much current will be only flowing.
Okay, okay, okay. I hope.
So if you see what will happen, suppose now battery has discharged to 100 volt. Now I will start charging with a 10 ampere of current. So to flow that 10 ampere of current, my converter has the voltage above that 200, say 210 volt. Now once if I keep the 210 only, then the current will reduce because potential difference will reduces
reduce.
as battery charges. So that case you have to increase that reference 210 to the 215 to keep the same current. So so that will be done like that only.
Okay, okay, okay. Okay. Any other
Any
doubts?
question?
Yeah, sorry, I got a question here. During the state of charge
Hmm.
of the batteries, the internal impedance of the battery changes.
Hmm.
So how do you manage the delivery of power when the impedance is high, when it's low, when it's linear, with this 300 kilowatt system? Do you swap from constant current to constant voltage delivery, or how do you manage that?
Yeah, as I said, see, miss any battery will have its maximum voltage. Okay. And if you want to
Yeah.
set constant current, as you said, the impedance changes, so you have to increase the voltage.
Okay.
But that voltage increase up to what? Up to the maximum voltage of the battery. Above that you cannot go. Otherwise, it
Mm,
will affect to the your battery.
mm,
So that is your limit. So till that limit only you can have the constant current. Once it reaches to that voltage level, you cannot further go for the higher voltages to keep the same current. Then you have to operate in the constant voltage mode only. So you have to keep stick to the that voltage only and charge the battery where the current will reduces then.
okay. So is it the BMS of the battery that um, informs the
Yes,
controls of the
yes.
charger and it
So
changes the
the
modes?
BMS is
Okay.
continuously gives the feedback of the battery states and the
Mhm.
battery voltage and that information to the charger to
Okay.
manage that one. So
Okay.
that's why
Thank
that
you.
proper communication is required between the vehicle and the battery charging system.
Yeah. Thank you.
Thank you.
Okay, so I think there are no more queries. So can I share my screen?
Yeah.
Yeah.
Please.
Just a second. So thank you so much for the very insightful talk, and I hope all the participants have learned at least something out of the presentation, if not all, and they might get some idea for their future research as well. With this, I would like to give a token of appreciation for to our speaker, and please accept this.
Thank you.
Thank you so much. And I will also request you to, can you please, in chat box, can you share your email ID to the participants? So if any participants have any doubt further, they can email you.
Yes, yes, I will do
Thank you
it.
so much for that.
So I will share my personal email
Sure, sure.
and contact on this.